Okay, we are ready now for notes in Geometry 6.3. Conditions for parallelograms. In 6.2, we also talked about parallelograms, so we're going to continue the topic of parallelograms. We start off with 3 theorems. Actually 5 theorems, but the next 2 are on the next slide. The first one, 6.3.1, it reads, if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. In other words, if you look over here, I'll circle it. The top and the bottom are both marked parallel and congruent. That means it's a parallelogram. Now the left side and the right side are not marked. But if they were, and the top and bottom were not, it would still be a parallelogram. The second one, 6.3.2 reads, if both pairs of opposite sides of a quadrilateral are congruent, in other words, the left and right are congruent, and the top and bottom, then it's a parallelogram. Notice, left and right have 1 tick mark, top and bottom have 2 tick marks. That means it's a parallelogram. The third one, if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. If you look, angle A and angle C, they're opposite, so they're congruent, as well as angle B and angle D. Those opposite angles are marked with 2 arc marks. If we have that, that means that 4-sided figure, that quadrilateral, is a parallelogram. Next slide, more theorems. 6.3.4, this reads, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it's a quadrilateral. In other words, if an angle, I'll circle X, if A and B, A plus B, equal 180, and A plus the other way, plus D, angle A and angle D, equal 180, then we have a parallelogram. The fifth and final one. If the diagonals of a quadrilateral bisect each other. Notice the diagonals. I have this half is congruent to that little half, and then the double tick marks there and double tick marks there. That means the diagonals bisect each other, so that's enough information to say we do have a parallelogram. So, with those 5 theorems, let's work out some examples. In this one, show that JKLM, so that quadrilateral, is a parallelogram for A is 3 and B is 9. Let's do the A is 3 first. Well, if I plug A is 3 in right there, 15 times 3 would be 45, minus 11, 34. So I put a 3 in place of A. That means that side length is 34. Let's do the other side. 10 times 3 is 30, plus 4 is 34. So that means I can go in and put a tick mark on the left and a tick mark on the right. Well, if the same holds true for the top and bottom, then I'm going to have a parallelogram. So now let's take and plug in 9 for B. Well, the top would be 5 times 9, that's 45, plus 6, 51. And let's see now if I get 51 for the bottom. 9 times 8, 72, minus 1 is 51. That means my top and bottom. I can put 2 tick marks in there. So do I have enough information to show it's a parallelogram? I sure do. Go back and look at theorem 6-3-2, the second theorem. It's why that quadrilateral is a parallelogram. Let's look at the next one. Show that this quadrilateral quadrilateral, PQRS, is a parallelogram. X is 10, Y is 6.5. Let's do the X is 10 part first. So if I put a 10 in there, that's 15 times 10, 150 minus 16, 134. Let's do that for the Y. Let's plug it in here. 6 times 6.5, that's 39 and 6, 46 degrees. And 8Y, this one here, if I plug in my 6.5, be 48 and 452 minus 6, that's 46 as well. Well, this goes with theorem 6-3-4, which talks about the consecutive angles, because 134 plus 46 is 180. Consecutive angles are supplementary. I have a parallelogram. So I just showed that that quadrilateral is a parallelogram. Let's do another one. Show that this one's a parallelogram. Let's do A is 2.4. So if I go A is 2.4, I've got to pick up my calculator. Let's do 7A. So 7 times 2.4, that's 16.8. Let's go over to the right side now. And that'd be 2 times 2.4, that's 4.8, plus 12. That'd be 16.8. So that means my left and right side are congruent. And then let's plug in the B. B is 9. So this would be up here. If I do this one, I'll go to blue. 10 times 9 is 90, minus 16, 74. And then over here, 81 plus 25 would be 106. Do I have enough information? I don't think I do. I don't think that follows the theorem. I know. I now know. I'll do it in green. These are parallel because 106 and 74 are, remember talking about two lines cut by a transversal? So I have supplementary angles. So I have the left and right side are both congruent and parallel. So this would go with the very first theorem, 6-3-1. Let's keep going. Slide 6. Determine if the quadrilateral must be a parallelogram. Justify your answer. Well, it looks like if I add up consecutive angles, they total 180. And going back and looking, what theorem is that? The 6-3-4 talks about consecutive angles being supplementary. The next one, number 7, determine if the quadrilateral must be a parallelogram. I see opposite angles are congruent. And I know that theorem 6-3-3 talked about opposite angles, but in 6-3-3, you need two pairs of opposite angles. In this diagram, I only have one pair. So this doesn't work. The answer here is no, it's not a parallelogram. Let's go to the next one. Do I have enough information here? Determine if the quadrilateral must be a parallelogram. Because these angles are congruent, think of that's parallel to that, and the top would be parallel to the bottom. But do I have congruent as well? Don't need it. Opposite sides are parallel. That's the definition of a parallelogram. I have the left and right parallel, and I have the top and bottom because of the transversal. So this would be a yes. Next one. Do I have enough information? I have the consecutive sides congruent. Those two and those two. But to be a parallelogram, I need opposite sides, and I don't have it. So is this a parallelogram? The answer is no. One more slide, and we're done. Just kind of a summary here. This last slide reads, you have learned several ways to determine whether a quadrilateral is a parallelogram. You can use the given information about a figure to decide which condition is best to apply. Conditions for a parallelogram. Both pairs of opposite sides are parallel by definition. One pair of opposite sides are parallel and congruent. Theorem 631. Both pair of opposite sides are congruent. Theorem 632. Both pairs of opposite angles are congruent is Theorem 633. One angle is supplementary to both of its consecutive angles, Theorem 634. And finally, the diagonals bisect each other, Theorem 635. Again, that last slide is just a summary page. Hey, thanks for watching. Good luck on these.